Lesson 7e, Friction Force. Friction force can be denoted with the symbol F sub F. It's a rubbing or contact force between two objects that resist motion. It is parallel to the surface and opposite in direction of travel. If friction force is large enough, it will keep an object from moving. Remember, a mass on a table will have force gravity acting down, and a normal force that is equal and opposite to gravity. Because the forces are balanced, the object is still. If we apply a force to the right, the object may move. If friction force is smaller than the applied force, then the object will move, and if the friction force is equal to applied force, then the object will not move. The same situation occurs on an incline. The force of gravity acts straight down, while the normal force is perpendicular to the surface that it rests on. Normal literally means perpendicular. Now, common sense tells us that some objects will slide down an incline, while others do not. This motion would result if friction force is smaller than the force of gravity that is pulling the object down the ramp. Here are the factors that will affect friction force. One would be the type of materials in contact. We know that rubber on concrete is pretty sticky, that's why we make car tires out of rubber, while steel on ice is pretty slick, and that's why skates are made of steel. The texture also matters. Smooth items are more slick than rough surfaces like glass versus sandpaper. The coefficient of friction, which is denoted by the symbol mu, it sort of looks like a backwards U. It's a unitless value used to describe the stickiness between two types of material. A larger coefficient of friction means the interaction between the materials is stickier. It's used to calculate the size of friction force. And finally, normal force. Normal force is a force that counters force gravity, weight. So the heavier an object, the stickier it becomes. It presses down harder, increasing the friction force. Calculating friction force is pretty easy. The formula for friction force is mu times force normal. If the object is on a horizontal surface like a desk, then the magnitude of force gravity equals the force normal. So force gravity equals mass times gravity. Then force normal also has the same magnitude as mass times gravity. So we can simplify force friction as mu times mass times gravity. There's two types of friction: kinetic friction, F sub Fk, and static friction, F sub Fs. Kinetic friction is the force present when two objects are already moving or sliding over one another. It counters movement and results in slowing down of the moving object. It can be used in free body diagrams to calculate F net and acceleration. The second type is static friction, which is a force present when objects are stationary and an attempt is made to move them. It's the force that resists the object from initially moving. It's a necessary type of friction when we want movement between two parts, like shoes on the ground or tires on the road. Without static friction, shoes would slip and tires would spin without transferring motion. An example of these two types of friction can be seen when you're trying to move something heavy like a refrigerator. If you apply a small force, you may not overcome static friction and the object will remain still. You can apply an even greater force, but still not move the object if the applied force is less than the force of static friction that's resisting motion. However, let's say you apply a great enough force to overcome static friction, and the fridge begins to move. What you will notice is that once you overcome static friction, you can accelerate the fridge with much less force than you needed to start to move. Once an object is moving, kinetic friction force is less than static friction force. In Physics 11, we will only look at two scenarios. Will the object move? Is the applied force greater than the static friction force? And if the object does move, what's the acceleration after it has begun moving?